Okay, welcome to Unit 5. Unit 5 is about reciprocal and rational functions, but the umbrella term would be rational functions. We'll talk about the difference between reciprocal and rational as we move through the unit. Today we're going to start with reciprocal functions. Reciprocal function is the reciprocal of an original function. Reciprocal means that you're flipping the fraction, or you're doing 1 divided by the original. So if we had a function, say 2x minus 4, its reciprocal would be 1 divided by 2x minus 4. So it's the original function, just flipped 1 over the original function. These two functions are called reciprocal of each other. This is your original, this is your reciprocal. You can take the reciprocal of any function f of x by just doing 1 over that original function f of x. So the first part is kind of an investigation. I want you to graph the original function between -4 and 4, get your y values, and then graph the reciprocal by also looking between -4 and 4, but the y values would just be the reciprocal of the y values from the original. And you can do that or find that by either just flipping the f of x values to get g of x values, or when you plug in x, you'll find that the g of x is just 1 over whatever the original f of x values were. So what I'm going to ask you to do is I'm going to ask you to graph the original, the reciprocal, on this Cartesian plane, and then continue playing the video. So at this moment, I get you to pause it and complete your graphs. Okay, hopefully you've had a chance to graph both those functions. So I have that completed here. We have an original f of x, which is just a line, 2x minus 4. And for these x values, we generated these y values, and we graphed our line f of x. To get my reciprocal, all I did was take my y values from my original and flip them. 1 over those y values are the y values of the reciprocal. And you could also get that by just plugging in your x values into the equation of your reciprocal function, and you could end up with the same y values. Something unique happens though when we get to 2. When we plug 2 in here, we get 2 times 2, which is 4, minus 4 is 0, 1 divided by 0. In grade 11, we learned that you can't divide by 0, and when you try to, you end up with a vertical asymptote. So there's actually a vertical asymptote here when x equals 2. And we could see that by, if we were to flip 0 over 1 to 1 over 0, we'd also again be dividing by 0, so we get our discontinuity in the form of a vertical asymptote. 3 and 4 have y values of 1/2 and 1/4, and if we graph those, we get a curve that looks something like this. This looks a lot like the 1 over x parent function, except it's undergone some transformations. And we could apply transformations to graph this. This would be a horizontal compression by a factor of 2, and a shift to the right 2. And if we applied those transformations to the parent, we would come up with that graph. But we could also come up with it by graphing the original, or the bottom, as a line, and then flipping it and graphing the reciprocal, which is what we did in this graph. So some key properties that I want you to be able to identify when comparing an original function and its reciprocal graph. And I've summarized those below here. And we'll see if we can pick all those out. The first one is that you have a vertical asymptote anywhere the original function equals 0, or anywhere the reciprocal would turn into 1 over 0, because we can't divide by 0. As the original function is increasing, g of x is decreasing, and vice versa. As the original function is decreasing, g of x should be increasing. So let's see if that's true. The original function, as we trace across, is always increasing. So we should expect the reciprocal to be always decreasing. And if we trace from left to right, we are relatively flat, but actually decreasing very, 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 very slightly until we hit here, and then we decrease very quickly. And then we hit an asymptote. On the right side of the asymptote, we're decreasing still very quickly, and then a little bit slower, 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 and starting to level off, but still decreasing. So over its entire domain, g of x is decreasing, while f of x is increasing. The only spot where it's not doing anything is at the vertical asymptote, because it does not exist when x equals 2. Okay. Finally, another key property is that the reciprocal of f of x passes through y equals 1 and y equals negative 1 at the same time as the x of f of x. That doesn't make sense. At the same time as g of x does. What that means is you'll have a shared point when y is 1 and negative 1. So if we look on our graph at when y is 1, both f of x and g of x are at the same spot. Same here at negative 1. When y is negative 1, both g of x and f of x cross. The reason is because the reciprocal of 1 is 1. 1 over 1, if you flip it, is still 1 over 1. So when the original function equals 1, that's its y value. To find g of x's y value, you'd flip it. If you flip 1, you get 1. So there's a shared point there. Same with negative 1. The reciprocal of negative 1 would be 1 over negative 1, which is still negative 1. So we have shared points between an original graph and a reciprocal when y equals 1 and y equals negative 1. And that's going to be a very important tool that we use to graph reciprocal functions going forward. So that's coming up with a graph from a table of values. The second thing I want to look at is how to come up with a graph from a graph of an original. And the way we do it is we use those properties that we just discussed from the first function. We can start by looking for if there's going to be any asymptotes, any vertical asymptotes. And we know there'll be a vertical asymptote wherever the original function equals 0. Because if we want to graph the reciprocal, basically we're just taking all the y values of all these points and finding its reciprocal. Well, the y value right here is 0. The reciprocal of 0 is 1 over 0. Therefore, the reciprocal graph would be discontinuous when x equals negative 2. So we'd have a vertical asymptote at x equals negative 2. Also, we know we're going to have shared points when y is 1 and negative 1. So that means when y is 1, right here on our original graph is also going to be a point on our reciprocal graph. Same over here at negative 1. Negative 1 on f of x is going to be a shared point for g of x. To find a few more points, we would just need to look for some y values and then find their reciprocal. Here's a nice point right here. It crosses at y is 3. The reciprocal of 3 is a third. A third would be down here. Okay, the y value stays the same, and we take the reciprocal, or sorry, the x value stays the same. We take the reciprocal of the y value. This one looks to be about 4.5. The reciprocal of 4.5 is 1 over 4.5. 1 over 4.5 would be even smaller than a third. It would be down here. I think you might see what's happening. As these numbers get bigger, these fractions would get smaller. As we go here, this is 2. 2 is a half, so that'd be a point right here at a half. This is 1.5. The reciprocal of 1.5 here. This y value is a half. The reciprocal of a half is 2. That value is up here. And I think you can see what's kind of happening here. We're going to bend towards our vertical asymptote. And then this seems to be bending towards and leveling off at 0. And that's because there's actually a horizontal asymptote at y equals 0. And we're going to discuss more about why there's vertical asymptotes and why there's horizontal asymptotes in rational functions. But in a reciprocal function, there's going to be a vertical and a horizontal asymptote. And the horizontal asymptote is always going to be going through y equals 0 for our reciprocals. Okay, if we want the other piece to our graph, we can go here and we can reflect a few y values. So here the y value is 2, negative 2. The reciprocal of negative 2 is negative a half. Here we have negative 3. The reciprocal of negative 3 is negative a third. And we're going to get the same shape. There's a half. The reciprocal of a half is, negative a half is -2, so we get a point here, and we can connect these with a nice smooth curve. And there is our reciprocal function. We'll call it 1 over f of x, graphed from an original graph by using key properties of reciprocal functions. That's it for video 1. Pick up with part 2